All right, let's go ahead and get started because this is not Eric's walking guide to Boston, although I do recommend going. Boston was fantastic. This is an intro to Python class, and I am super happy to be teaching it to you tonight. My name is Erik Gross. I am the co-founder of the Tech Academy. More on that later. I'm a senior level software developer, and I'm a vet. I was in the Navy for 6 years. I was an electronics technician and nuclear reactor operator, and all around nerd. Got to visit like 7 or 8 different countries while I was in the service, which was really great, and got to do a humanitarian mission over to the eastern edge of Africa in a tiny little town, or sorry, tiny little community country, actually called Djibouti. Funny name, really seriously sad over there. You know, the whole point is that I've been around the world a lot and seen a lot of places, and I'll tell you a couple things. One, people are awesome everywhere. There's really, really good people everywhere. And two, we're all just trying to like survive well and do well by ourselves and our families and our loved ones. So you'll find that kind of a theme, caring about people and helping them achieve their goals runs all the way through who we are as the Tech Academy. So again, more on that later. Just want to share a little bit. So yeah, that's me. We have our assistant inside the chat. Well, inside the meeting, she runs the chat. Regina's here. She monitors the chat, answers questions. And if you're not nice, she'll boot you. We rarely have problems with that kind of thing. A couple things about the class. They will be challenging. Now, don't get me wrong. These are introductory classes, and we attempt to make them as easy to follow along and actually go through. Like you'll actually be coding, right? You'll actually be writing programs, right? We try to make them as easy as possible. That said, they are challenging. For if this is your first exposure to coding, it's a bit unfamiliar, and there's new concepts and everything, right? But we get you through it, and you'll learn a lot. No, Jeremy, I will not boot the loyal attendees. Just as long as you don't insult the 49ers, we're going to be fine. One of the quick thing about like doing the actual coding, and I just want to remind everyone of this right now, and then when we get into the actual coding, remind you of it again. Try to write the code exactly as I write it. Ensure the code is written exactly as written. The reason for that is a misspelled word or a missing symbol or even something capitalized that shouldn't be capitalized can result in code errors. And it just has to do with the very strict nature of how it's just a machine, right? It'll only do what you tell it to, and you have to tell it what to do in a pretty precise manner. The good news is, once you learn the basics of how to do that, you can always look up the right way to put the instruction in, which is kind of cool. Another point, if you're attending on a mobile device, you can listen, but not code. I've never seen a real good experience being able to code on a mobile device. I've experimented with it sometimes that just for fun, but it's not that easy, right? Now, that said, if you're on a mobile phone, please do listen. You will learn a lot. And you can always go back and watch the recording afterwards on a desktop or a laptop. Hello, Zoje. I hope I said that right. Okay, good. Make sure you're in a distraction-free environment. Again, while I am going to attempt to make these concepts relatively simple to understand, it is intellectual work. It does require learning new things and then putting them into practice. And that's difficult to do when you're surrounded by, 3 children, a dance hall next door, and a clown convention outside. Give yourself a nice distraction-free environment so you can focus on the class and so I don't lose you. That said, if you fall behind, don't worry about it. Just listen and learn. If you get lost, you can't keep up, stick around because you still will learn a lot. I already referred to this a little bit in terms of the recording. The recording of this class will go up on our YouTube channel later today or tomorrow. They go up really, really fast. We'll get you links to all of that at the end of the class, right? And we're going to be doing some coding today. You can be writing code and getting your hands dirty. We're going to be building a tic-tac-toe game. You're going to get full code, all of the code for that game at the end. You'll be able to play the game. You'll be able to, keep that code and mess around with it and learn more. And as I already said, there's links for a bunch of stuff that we're going to share right at the end. All right. I've already had people, kind of share a bit of who they are, but if you're new to these classes, if you've never attended one, and you haven't already shared where you're joining us from tonight, please pop into chat and let me know where you're joining us from. Reem joins us from Portland. Laura's in Portland. Oklahoma. Spent a lot of time in Oklahoma in the 90s. Love it there. Zoji's joining us from Berlin. That's fantastic, man. Lauren's from Florida. We got more Portland, Lehigh, Utah. Beautiful area. That's fantastic. Well, welcome all of you. We usually get people from all over the country and obviously even overseas. And we're super happy you're all here. And we hope you find this class enjoyable, but most importantly, very helpful. If you are contemplating going into technology and you're trying to figure out, is coding for me, you'll be able to get your hands dirty in actual coding. I do want to stress something. We just had a whole class about this the other day. There's a lot of things, that software engineers and developers, technologists, there's a lot of things we do throughout our day. Only a small portion of it is actually writing code, but all the other things you do revolve around an understanding of programming and being able to collaborate with other people on creating complex programs. So everything you're learning tonight is super important. I just like to let people know that when you're a software developer, you don't spend 8 hours a day typing away at the computer. You might spend 1 hour a day, an hour and a half actually. And there's a lot of other things you do. If you're interested in what else you do, then look on our YouTube channel. Again, we'll get you links at the end. And we just did a day in the life of a software developer. It's about an hour, hour and a half. It was a blast. I got to just download what it's actually like to work in this industry. And people had a lot of fun and I enjoyed it. Awesome. Dr. Ford is joining us from New York City. Fantastic. Glad you're here. All right. Here's the agenda. We'll have a very short explanation of the Tech Academy, who we are. We're the ones putting on these free classes. Then we're going to write code. It's a blast. There'll be a brief Q&A session. But I want to let you know, I am monitoring the chat, and so is Regina. As available, I'll grab some questions that come up during the actual coding portion. But sometimes I just need to keep on going, and we'll pick up the question at the end of the Q&A session. After we're done with that, we'll go over some information about our boot camps. A boot camp, by the way, is one of the 3 ways that you can break into the industry, into the tech industry. You can self-study, you can go to a college or university, or you can go through a boot camp. And we're going to talk about our boot camps. And please stick around to the end because we have a free gift for you. The whole class takes about an hour, hour and a half. All right, so who are we? Well, we're the Tech Academy. We run coding boot camps. Coding boot camps are intensive technology certification programs, and they're designed to prepare people for entry-level positions in the technology industry. Typically, coding boot camps last 3 to 6 months, that kind of order of time, and they focus on modern, practical skills. And we've been offering thorough, budget-friendly, flexible, trusted coding boot camps for over a decade. We're really proud of that. We were here right at the very beginning of the boot camp industry. I think the boot camp industry had been around for 6 months, before we started figuring out, breaking into this area. Another thing about our certification programs, about our boot camps, they're cost-effective, they're self-paced, they're online, and they're tailored for beginners with no prior technical or coding knowledge. And they cover in-demand skills for the tech industry. They're endorsed by stellar online reviews. And this is really cool. They're designed to fit around your personal schedule and to prepare you for your technology career with a well-rounded toolkit. The average cost of boot camps, at least in America, is $13,500. If you look around, at all the various providers, ours are under the national average. We even have programs starting as low as $5,300 for tuition. And I like to read our mission statement. This is why, like, the very fact that we're having these free classes is actually totally in line with our mission statement, which is to graduate entry-level technology professionals that excel in the basics of their field, and thereafter have successful careers in the technology industry, and whose actions raise industry standards and surpass client expectations. Our product is you working in tech. So that's who we are. Now, I want to tell you about something really cool that just started a couple of weeks ago. It's a brand new service from the Tech Academy. It's called the Tech Academy Accelerator. It's a monthly subscription program. It includes live weekly workshops with me, over 100 educational videos, over 100 self-paced online mini classes. And what's really cool about these is that, the classes we do, like the one you're in now, they're really introductory, right? In the accelerator, we do a deep dive into complex technical subjects. There's a whole lot of Q&A included. There's open chat and voice communication. It's a back and forth community, right? And the topics that we cover are suggested by the community. Here, when we do these free classes, this is sort of it's really introductory, and we've determined what we're going to do. They're very valuable, not knocking them at all, right? But if you want to be able to have a say in a subject you're super interested in, that's part of the Tech Academy Accelerator, which we love. And there's a community aspect of it. There's a whole platform online where all the courses are, and there's chats in there, and it's a community. And the cool thing is, it's only $9.99 a month. It's like nothing. And you can try it out for free for a week. You get your first 7 days free. Regina's just posted a link to that accelerator in the chat. For anybody who's interested in that, I'm going to give you a moment to fill out that form if you click on the link in chat. And I'm going to take a sip of coffee. Yes, I drink coffee late at night. I don't know what to say. I think it's because I was in the Navy. You grab your sleep and your food whenever you can. By the way, when you apply for the Tech Academy Accelerator, you fill out a real simple form. You'll confirm your email, and then they'll ask you to enter your card number. You will not be charged. You have 7 days free. It's built in. We're technology nerds, so we made it so that it doesn't charge you for a week, right? And you can cancel anytime. So what I recommend is sign up now, attend the first workshop, and if it's not for you, just let us know. You won't be charged. And these workshops are fantastic. They really are. We get great suggestions from our community, and I just get to I get to just let loose and talk as a person who's been in technology and coding and engineering for decades. I love to teach, and I love to just dump all that information. I can do that in the accelerator. All right. Let's talk about Python. I want to cover a couple basic definitions before we get started, because we're going to be learning to code, and we happen to be using this language called Python. But let's first just talk about programming. What is a program? Well, a program is a set of instructions that you can enter into a computer that basically tell it what to do. They make the computer take action. Remember, the computer is just a machine. It's got a certain number of built-in things that it's capable of doing. And when you make a program, you're making instructions to tell the computer what to do. And that action is called programming. And we do it with a programming language. You're going to write down instructions in a form that looks almost like English. It uses English words and symbols, but it's a very precisely formatted language that lets you communicate with the computer and tell it what to do. And you use these languages to create programs. So the action of entering those instructions in, the action of making a program, is called coding. And finally, what's Python? Well, it's awesome is what it is. There's a lot of different computer programming languages, thousands, literally, right? This language, Python, was created in the late 80s by this really, really talented technology professional named Guido van Rossum. My co-founder, Jack Stanley, was fortunate enough to interview him very early on, not long after we actually started the Tech Academy. And it it made us so happy we could do so. And he's just a treasure of a man. Great guy. Python's really cool for a couple of reasons. It's very easily readable. So for the new person to technology, it's pretty easy to read Python and figure out, for the most part, what it's doing. What is the program intended to do, right? And it's really versatile. You can use it to make mobile apps, desktop applications, websites, games. You can use it in a lot of different areas. It's also very useful in this whole area called data science, which is a discipline where you extract meaningful insights from large sets of data. So Python's very, very powerful and versatile. Now, I guarantee you, we are going to start coding soon, okay? But I'm going to give you a little picture here of how we approach creating a competent technology professional at the Tech Academy. We do not throw our students into coding on the first day. We found that trying to write a bunch of code without a solid understanding of the fundamentals underneath that machine that you're using makes it very difficult to understand what you're actually doing. And this data that's going to be on this slide is some of the most important data we teach in the very early portion of all of our boot camps to orient people to what are the basic building blocks of any computer program. Because once you know these things, and there's only 5 of them, once you know these and know them well, 1, you can learn any new language much more easily, any new programming language. And 2, When you are tasked to go to work on a computer program, let's say you go all the way through a boot camp and you get hired and you're on the job, right? When you are given a computer program to work on and you didn't build it, you've got to dive into this thing and understand what's going on. It's only ever going to use these 5 things. And so when you learn to identify them and what the purpose of them is, it just helps you understand that brand new program that you've never been exposed to. Now, enough said on it. Let's teach you these 5 things. The first element of a computer program that has to be there is what we call an entrance or an entrance point. It's just what's the first instruction that's going to be performed. Remember, a program is a set of instructions, and they're executed from the first instruction and then the next and the next and the next, all the way to the last one. It's how programs work. Almost think of it as a recipe, right? You do things in an exact order. So it's actually, one, every program has to have an entrance point. It's got to know where to start, right? The computer has to know where to start. But 2, it's really important for a lot of reasons. One of the most significant reasons why it's important to know where in this giant program is the very first instruction is this. Let's say you are on a job. You got that brand new position and you're all excited or nervous or both. And you're assigned to work on a specific computer program. Probably that program has been around for a while and had a lot of people develop on it. And it's probably pretty big and complex. And it can be overwhelming. You're trying to figure out, how does the program work? What does it do? One of the coolest things you can do is find where is the entrance point in that program. And there is one, I assure you, is to find that instruction that is the first thing the computer performs once you say, start program X. And the reason for it is that you can then start to go through the code, the program on your own, and follow along with what the program does. If you were to start somewhere halfway through the execution of the program, halfway through those instructions, you'd be lost. And so an entrance point is valuable for that reason alone. Next element of a computer program. And again, these are the basic things that every program has. They have to have. Right? A program has to have these. These are not in order. When you build a program, these things are not necessarily in order. They're just the building blocks of a program. The next one is called a variable. Now, it's not going to shock you probably that computer programs have to work with data. I hope that doesn't shock you. In fact, this isn't even in the slide. I'm going to give you this for free. The purpose of a computer is to take in data, process that data in some way, and then send the data on somewhere else. That's actually all a computer is meant to do. Take in the data, pass it, process it, and then send it on. So, of course, computer programs work with data. Now, here's the thing. There's lots of types of data your computer program could work with that are going to change in value while the computer program is running. A simple example might be if you have a program that keeps track of the total number of items you have in inventory of a certain model of toaster, right? You're a consumer goods company and you have physical inventory in a warehouse and you have people entering records into the computer, and now the computer's got data. Well, that data, the number of units of toaster X5000 that we have in the warehouse, that could change, couldn't it? So your computer program must be able to keep track of data that can change. Those are called variables. And all it is a way to keep track of data that can change. But if your program didn't have that, the program would be of very limited usefulness. Next element of a computer program that must be there for it to have any value to human beings, it's got to have mechanisms for control and branching. I'll explain what that means. Remember how I talked about the idea that if you're going to enter these instructions in, the program would go to the top one and then do it, and then the next one, and the next one, and the next one. Well, it's inevitable that one of these instructions will need to be, hey, computer, I need you to make a decision. I'm going to give you a condition that you need to check. You've got to check whether something's true or false. And based on whether it's true or false, you're now going to do one of 2 different things. Now, it can be a bit more complex than that. You can build it so there's any one of 10 different things. But look at the concept, which is there's 2 possible options. Those 2 possible options, we call those branches. your code will now have branches. You've been going along, doing one instruction after the other, and all of a sudden, you're going to have the computer make a decision. And based on its evaluation of what you told it to look at, it's going to go one way or the other. And there's a separate set of instructions for each. That separate set of instructions is called a branch. And so you've got to have a control instruction that tells it, hey, make a decision. And then you have to have branches based on that decision. If your computer program does not make use of these, it's of extremely limited use. Because guess what? We use computer programs to automate manual actions in working with data. And one of the things we do all the time with data is we make decisions. Maximum number of students in a class is 30. When you go to add a student, you better check whether or not the number of students in that class is already 30. If it is, then you can't add the student. If it isn't, then you can add the student, as an example. So these have to be parts of your computer program. And finally, one of the coolest ones, well, not finally, there's two left. Subprograms. Think of these as programs within your program. And here's how they came about. This is actually a little bit of a history lesson, right? If you go back 50, 60, 70 years ago, when people are first getting into this computer programming thing, they have these massive computers called mainframes. And the first professionals in the area are figuring out how to, enter in instructions and make the computer do work, whether it's processing financial records or, calculating probabilities or whatever, right? So there's these set of instructions. And what these first computer programmers found was that for any particular program they were writing, it was extremely common to experience the following. There would be a certain action that would be needed in their computer program many, many times as the computer program ran. And so what they'd find is they were typing the same 5 or 10 instructions over and over again. Now, that's a giant pain for two reasons. One, besides the fact that you're typing all this stuff over and over again, it's really easy to make a mistake and forget one of the instructions or type it wrong. Every single time you have to type out that series of instructions is one more possibility for an error. But two, what if you need to change the way those 10 steps, those 10 instructions, for example, are done? Now you've got to go back through your program and find every single time you wrote down that exact series of instructions, and you've got to change it. It's really hard to maintain your program, to upgrade it, to improve it. And so what they came up with is the concept of subprograms. They said, all right, so there's these, say, 10 instructions we keep on using. Let's put those stored in a separate place and give them a name. And then while we're going through our program, one instruction after another, when we need that thing to occur, that set of, say, 10 instructions, we'll just call on the place where we stored it and say, hey, do those things. And when you're done, come back here. Now, I know I'm being real casual in the way I talk about it, but guess what? That's actually what happens inside the computer. The computer's doing one instruction after the other, and it hits this place where it says, hey, go do this pre-created set of instructions, and when you're done, come back and pick up where you left off. That's what a subprogram is. And they're super, super valuable. And so I hope you can see that if you don't make use of those, you have a very, very poor program. All right, last element. There needs to be an exit point. In the same way that we need an instruction that is the first place for the computer to start, say, hey, start going through this program, we need an exit point. We need a point where the program is telling the computer, hey, I'm done running. No more instructions. If there was anything you, the computer, were doing to support me, the computer program, then you can stop doing those things because I'm done. So again, there's a lot of nuance to these, but the fact is these are the only things you will ever find in a computer program. And what we're going to do in terms of coding tonight is we're going to build each one of these things. We happen to be doing it in Python, but that's all we're doing. Now, let's get to it. So when you are writing your code, your program instructions, you write them in what's called a code editor. You can see in chat that Regina's just dropped a link. This is going to take you to our code editor. Now, I'm going to open this up and show you what we're looking at. This is what you should see. On the left is where your code is. Don't worry about all this stuff. We're going to erase it and do our own. But this is your code. And on the right, this whole window here, or this separate section of the page, this is where the output will be based on what your instructions are. So this is your code editor. All right. The link should be right in chat, Nathan. If you go to chat, Regina dropped it in. Let me know if you don't get it or if you have an issue. Okay. All right. So here's what I want you to do. Okay. I want to have it so you have two things side by side. Well, maybe I should learn how to run PowerPoint. So we're going to have two things side by side. On the left, you want to have the instructor's presentation, i.e. Zoom, because I'm in your stream on Zoom. So you want me on the left, and on the right, you want your code editor that you just opened. You have a web page open with the code editor. You want that on the right-hand side. Now, instructions vary on how to get this done. Most people know how to set stuff up side by side, but you have any kind of questions to set up a split screen. Sometimes the Zoom program isn't very cooperative in trying to resize it and move it to one side. Sometimes you have to click on the little words that say Zoom meeting right here, and this little drop down will appear. If you click on restore, it should suddenly make your Zoom window smaller, and you can move it around and resize it. And that's the one that has me in it. So if you set this up properly for the web browser, watch what it does here. There's this little symbol here with two different windows. When you click on that, it makes the web tab or the web page smaller. So those are two different ways to resize what you're looking at, and you want to have them side by side. All right. Let's start coding. I can't wait for this. Is so much fun. All right, so let me switch over to where you can see my code editor. Okay. We're going to be building a tic-tac-toe game. And the first thing I want to do is I want to show you the actual game. So I'm not going to give you all this code. Just sit tight for a second. You'll get all this in a moment. Well, in a little while. If we go here, this is a whole bunch of code. And don't worry. We're going to go through this towards the end, and you'll find that you actually understand a lot of what's going on here, which is awesome. But if we run the code, the output will appear here on the right. So I'm going to run. And we're looking at tic-tac-toe. We have rows and columns. Rows A, B, and C. Columns 1, 2, and 3. So I am going to put I'm going to go A1, upper left-hand corner. So there I am. There's me in the upper left-hand corner, and the computer went to the bottom right-hand corner in C3. All right. Well, I'm going to go to, let's see, A3. There I am at the bottom left. Ah, ha, ha, ha. So if I go A2, I should win. You win. So that's it. Look, it's not a very complex game. I got it. But I don't know about you. It's kind of cool. That's the game that we're going to be building part of today. What we're doing is we're going to teach you those 5 elements of a computer program using Python, and we're going to use examples that come from a game like tic-tac-toe. All right, so let's go ahead and do that. All right, so here's what I want you to do. Your code should look like this right now. I want you to erase all of it. You can select it, hit backspace. I want everything gone. Okay, so remember I said the 5 elements. The first one is an entrance point. Now, most computer programming languages, including Python, the first instruction at the top of your file is going to be what gets performed first. So let's just put an instruction in. We're going to use a command inside of Python called print. It does almost exactly what you probably think it does. It prints something to the screen. In this case, it'll print it over on the right-hand side. So the command is print, P-R-I-N-T. I want you all to follow along and actually write this code. Now, this is our first chance to just talk a little bit about how languages work and how to get them to do what you want them to do. If you're using a built-in instruction inside of Python. And print is a built-in instruction. Guido van Rossum, the guy that designed Python, said, hey, there's an instruction built in here called print. And the way he built it is this. You use the word print, and then in parentheses right after it, you include what is it you'd like to be printed on the screen. So let's do an open parentheses. Now, notice what's nice. This code editor automatically created the close parentheses for you. You didn't even have to type that out. That's just a feature of the code editor. Now, what we want to print here, we want the phrase hello world to be printed to the right. The way you give this print command text that you want it to print, there's a few different ways, but the most common one is to take the text you want and put it inside of double quotes. So I want you to do a shift and then hit that double quote. Notice that the code editor is nice and friendly. It provided handily a matching double quote, and everything in between these two double quotes is what will get printed on the screen. So you can type hello world, H-E-L-L-O, comma, world, you mean exclam, or 3 if you want to. And when you have that all done, go ahead and click run. And we have our first instruction. You can see hello world over here on the right-hand side. Let me bring it over to make it a little easier for people to see. So we have our first instruction. Now, that one's pretty straightforward. I do want to say, add a little bit of nuance in here. When you start to build really complex computer programs, and they have lots of different files, most languages have a way that you can specify the exact instruction that will be the first one. You might not want it to be what's at the top of this file. Now, that's much more advanced, but I'm just letting you know that most languages, it's pretty simple. You tell the computer program what file to look at, and the first instruction in that file is where it starts. All right. Pardon me, a little warm. So let's start to talk about the second element of those 5 elements. It was variables. Again, this is saying, hey, there's a certain, element of data that I need to keep track of in my computer program. And this data, its value can change over time. Let's just say that our tic-tac-toe game is going to have different players. You've got you versus the computer. And let's say you'd like to be able to store the name of the current player. So we're going to create a variable and be able to set the value on that variable to your name. Pretty straightforward. In Python, making a variable is really simple. You type out the name of the variable. Let's make a variable called player. So hit enter to go to the next line and just type P-L-A-Y-E-R. Now, what you did with that one instruction is you made a variable called player. You haven't given it any value. What this really kind of corresponds to is like asking the computer to find a location inside its memory, because it stores data in these physical devices called memory, right? They're inside the computer, right? Little teeny electronic devices. And it says, hey, Mr. Computer, can you please find an available location inside all of the memory devices you have? And can you take that one location and give it a name? The name I'd like you to give it is player. That's all you've done. You have not told the computer what value to store in that location. In other words, your variable doesn't have a value yet. In Python, to give a value to a variable you just made, you use the symbol equals. So give me a space, there it is, and the symbol equals. Whatever is to the right of this equal symbol is the value that you are giving to the variable on the left. Now I'm going to do Erik, and it's alpha, it's letters and numbers, so I'm going to put that in quotes. That's how most computer programming languages work with text data. You have to put it inside quotes. So I'm going to put Erik. You put your own name. So you've made a variable called Erik. Now I'm going to clear up 2 terms. To the left of this equal symbol, when you've created the variable, that's called declaring a variable. You declared a variable called player. Now, we've already talked about what that means. The computer is going to find a location in memory and give that location a unique name, in this case, player is the name of that location. To the right of the equal sign, this is called assigning a value to the variable. So we've declared a variable and we have assigned it a value. That's what those two sections are. Again, this word right here, that declares a variable. This equals symbol followed by some information that assigns a value to the variable. Declare the variable, assign a value to the variable. That pattern is used over and over again in almost all computer languages. Okay, good. So, fine. We need to make use of this. Why don't we print the name of the player, the current player, on the screen? So, go to the end of that, hit enter, and let's use this print command again. P-R-I-N-T. And I already told you, whatever it is you want to be printed on the screen, you got to put it inside of parentheses. So give me a open parentheses. The computer makes the close parentheses for you. Now, this is where things get really, 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 really valuable. I know that this stuff seems really simple, but think about how powerful this is. What we're going to do is we're not going to print out the word Erik or Jim or Lauren or whatever your name is. We're not going to print that out. What we're actually going to print is the current value of the variable called player. So put that in here and just type player in here. And now when you run this, go ahead and run it. It does the first instruction. We assigned the value to the variable player, and then we printed the current value. So this word player here is a placeholder. It represents whatever the value of the variable happens to be at the exact moment this instruction runs. I'll show you how cool this is. Let's say someone else starts the game. Go down to the next line and type player, maybe you can spell it right, equals Joe. We just changed the value assigned to that variable. But when you run it, go ahead and run it, it still only says Erik. And the reason for it is on line 3, print player, it's going to print the current value of that variable at that exact moment in time. The computer does not know because it hasn't actually done, it hasn't performed this instruction yet, so it hasn't changed the value. But we are successfully using a piece of data, in this case, the name of the player, that can, in fact, change as the computer program runs. We could test that by now. Let's print it. Do your print, in parentheses, player again. And now when we run it, it should say Joe. Hey, it does. It'll say whatever your name is, whatever you put, and then it'll say Joe. Because that second time we called the print command, the second time we used the print command, the value of the variable called player happened to be different. Now, I know these are very simple examples, but I'm just trying to let you get you used to seeing that there are just these 5 things that are in a computer program. In fact, you only have to pay attention to 4 of them because the exit point, rarely do you need to do anything special with the exit point. So there's 4 things that if you know these 4 things, you can, it just helps you so much to learn a programming language and to understand a computer program that you're looking at. Now, there's a lot more to learn, okay? But these fundamental building blocks of a program can help you a lot. All right, good. So we've got the entrance point. We've got our variables. Now we get to the fun thing of control and branching. We need an instruction that we can use to control which direction our computer program goes in. So here's the situation we're going to put into code. We're keeping track of how many symbols a certain player has in a row. If my symbol is X, I'm the player, and then there's the computer, right? If we're keeping track of how many like X's there are in a row, that's a pretty important piece of data to keep track of, wouldn't you say? And every single time a player puts down an X, we need to check whether or not there are 3 X's in a row. Because if there are, hey, the player won. That's a big deal. So we're going to, and by the way, this is where the control and branching comes in. The moment we check that, the moment we check whether or not the player has three of his or her symbols in a row, we have one of two different things that are going to happen. If he or she does not have three in a row, all right, the game's still going. It's the computer's turn now. But if in fact the player has three in a row, hey, the player won. Game over, yay. So now you see there's two branches. One branch is instructions to be performed if in fact the game is over, because you won. And another set is of instructions to be performed if the game isn't over. And that's all there is to branching. Now, the most common way to do that in Python is using an instruction called if. And the way if works is this. Go ahead and type if. When you use this command, this is a control command. You need to give the command something it can use to make a decision. In other words, you need to give it something that is either true or false. And based on whether it's true, you can write instructions to do one thing. And if it's false, you can write some instructions to do another thing. Great question. Walter asked, does it need to be in line 7? No, you put it on line 6. I just put it one line down to make it a little more readable with what I was doing. This extra blank line here doesn't do anything. Great question, Walter. Thank you for catching that. So the point is that when you use this if command, which is a controlling command, you need to give it a condition that it can check. Check whether something is true or false. You give it the condition inside parentheses. So give me another open parentheses. Now, what do we need to check in here? Well, we need to check whether or not the player has 3 of their symbol in a row. Now, in the actual computer program, there's a bit more complicated logic than we're going to use. It's not my intent to take 2 hours and teach you how to build this whole program. You'd want to kill me by the end of that, okay? What we're going to do is we're going to cheat a little bit. We're going to go right back up one line right there. We are going to use line 6, Walter. We're going to create a variable that stores a really important piece of information. How many in a row does the player have? 1, 2, or 3? So we're going to make a variable to store that information. And we're going to call it player in a row. There's our variable. Type it out exactly the way I did it. Player in a row. Now, let's pretend that in fact, all the computer can find is 2 of their symbols in a row. So we'll give it the value. So give me an equals, and we'll assign it a value 2. All right. Well, we need to check whether or not the player has won or whether they need to keep on trying. And that's what we're going to use our if for. So go back down to this if, go right inside those parentheses, and let's give the computer something it can check to see whether or not it's true or false. All we're going to try to check is, hey, you know that variable called player in a row that keeps track of how many of the player's symbols he or she has in a row? Is the value of that equal to 3? Because if it is, yay, the player wins. If it isn't, you got to keep on playing. So to do that, to create this condition the computer needs to check, inside these parentheses, you're going to take the variable called player in a row, in other words, the current value of it, and you're going to see whether or not it's equal to 3. So let's type out the name of the variable, player in a row. Make sure you type it out exactly the way you did before. And now here comes the magic part. There's a special symbol inside of Python that tells the computer to check for equality, to check whether 2 things are equal. Give me a space. The symbol, and this is true in almost every programming language, by the way, the symbol for checking equality is 2 equal symbols. So give me 2 of those, and then a space. So you can see that we have something contained inside these parentheses. We're going to check whether or not the value of the variable is equal to something. What do we want to see if it's equal to? 3. So type yourself a 3. Now, if that is true, If the player has 3 in a row, then in fact they won and the game is over. So we need to tell the computer what to do if that condition is true. The way you do that is this: go to the end of this line, right past the parentheses, and give me an equals. What this will do is it ends off the if. The if is a control statement, and it says, hey, listen, does it count from 0 or 1? That would be built into, that's a question from Robert. Does it count from 0 or 1? And it's a good question. When you look inside the actual computer program, you'll see the exact logic. And I know where you're coming from on that question. We're talking about whether or not they have any in a row, and it's possible they have none in a row. So I guess it would start at 0. But it won't change what we're going to do here. We're just simplifying the logic that the actual computer program has, by the way. But let's just look at this in a real simple, simplified way. If the player has 3 in a row, we do one thing. If it's less than 3, we're going to do another. So what this colon does at the end of this if line is it tells the computer, hey, the very next instruction on the next line, if you format it correctly, which I'll tell you about in a moment, the very next instruction on the next line is what you should do, Mr. Computer, if in fact the condition is true. So what do we want it to do? Well, hit enter, and I want to show you something really cool that happens. Everybody notice where my cursor is. Take a close look at that. You notice my cursor is 2 spaces in. It's 2 spaces in right there. The computer, the code editor did that for us. Now, why? Because the designer of Python made it really easy to set up the instructions right after an if. He basically said, listen, whatever it is you want to have happen, if the condition is true, just indent it, like move it over by 2 spaces. That's all you do. And then whatever instructions are there, those are what will be done if the condition is true. So what we want to do, we're going to make this really simple. In the game, there might be a little more complex logic. We're going to print, you win. Well, I think you guys could do that all on your own, but let's type it out, print. And then what you're going to print goes in parentheses. If it's text, you put it inside of double quotes. And we're going to say, you win. Yay. I'm going to wait for everybody to catch up. And I'm going to ask, now, everybody pay attention. I'm going to ask a very precise question. When we run this, don't run it yet. If you've already run it, don't try to answer this. When we run this program, I want you to put into chat exactly what you think would be printed over on the right-hand side. Put that in the chat. What do you think is going to be printed over on the right-hand side? All right, I have, it says Joe, nothing other than what you see now. You win, nothing. Eric, Joe. Okay, good. All right. So the people who answered nothing, I want to address why you might think that. And Marcy hit the nail on the head because 3 doesn't equal 2. Now, technically, the people who said nothing are only partly right. Because what happens when I run this is the first earlier statements and then this statement or the first instructions. So let's run it. And look what happens. We get hello world, then your name, and then Joe. So for the people that answered nothing, you're correct. Except you're not. And there's a really valuable lesson here. 2 things. And this first one is actually probably one of the most important lessons about computer programming and working in technology. To succeed in technology, in my opinion, you need to be extremely willing to be wrong. Because what we do is we set up like what we think is going to happen over and over again. And then we run the program to see whether what we think would happen is what happens. And here's a newsflash. You hardly ever get it right the first time. You may see, in fact, if you've done any sort of coding tutorials, like on YouTube or any stuff like that, you see them type things out and they work right every single time. It's perfect. That is not what happens. Mistakes get made all the time. And you think you built it the right way, and you're wrong. So, being willing to be wrong over and over and over again in exchange for that glorious feeling when you get it right, that's just part of coding. And so I want to let people know that. But the second lesson here, precision matters in computers. I asked the question very precisely, not to be a jerk and try to catch you all up on anything, but just to illustrate a point. The quality of the question you ask and the nature of the question you ask is just as important as the actions inside a computer program. You got to know exactly what to expect as output. And yeah, I know it is a gotcha question. It's not what it's intended to do. I just want you to think with, oh, when I start this program up again, it's going to go back to the beginning. So there's that. Now we have part of control and branching set up. Why do I say part of? Well, we've got control. We've successfully put in a condition that has to be checked. And we have one possible path. Here's another super important lesson. You've got to account for all possible options. What do we do when the value of the variable player in a row does not equal 3? We better have some option. The way you do that in Python is this. Go to the end of your last line right after you win. This next part's important. Hit enter once. Notice where your cursor is. I'm gonna cover this because when you're learning a new language, particularly Python, this next thing is the cause of so many pieces of frustration for people. Where the cursor is right now, the flashing cursor, where it is on my line 9, we're still putting down instructions that will only happen if the condition inside our if instruction is true. But that's not what we want to do. We want to start over and say, all right, what do we do otherwise? What do we do if it's not true? But you can't start writing the instruction where the cursor is. You have to go backspace and get away from that if. You have to get out of the set of instructions that will only happen if the condition is true. All right, so now that we've done that, here's the instruction we can use in Python. It's almost like otherwise. The instruction is else, E-L-S-E. It basically means otherwise, right? It says, hey, if player in a row is equal to 3, do blah, blah, blah. Otherwise, do blah, blah, blah. And we're about to write that second blah, blah, blah. You see how precise I am? It's all those decades of experience as a software engineer. So that's all there is to it, though, in Python. It's like, okay, we built the first branch. The branch is my line 8. That's a branch of code. And it only gets performed, it only runs if, in fact, player in a row is equal to 3. Well, now there's an else. Else works the same way. We're about to give it another branch. Well, you need a colon. So put that colon in there, hit enter, and notice how this code editor is super friendly. It moved over 2 spaces for us. Now we're creating the second branch. We're now creating, what do you do otherwise? What do you do if player in a row does not equal 3? Well, what we want to do is we just want to print to the screen, keep trying, it's the computer's turn. Well, sorry, you're not at 3 yet. So we're going to do a print. Well, maybe it would help if my focus was in that window. Okay. We're going to do a print. And like I said, put it in open parentheses. You're probably used to this now. Give me some double quotes. And we're going to type, keep trying. It's the computer's turn. So keep trying dash. It's the computer's turn. So type all that in there. Don't run it. Do not run this yet. All right. Here comes the question again. You all know what it's going to be. Put into chat what you think the output is going to be when we run this. Kevin got it right. The output is going to be hello world, Eric, Joe, keep trying, it's the computer's turn. Many of you said the output was going to be keep trying, it's the computer's turn. Remember, when we run this, it's going to rerun everything. Start at the top. So go ahead and run it. And look, hello world, this will be your name. It'll be Joe. And then yes, absolutely, it'll be keep trying, it's the computer's turn. Okay, so we're successfully moved through 3 of the 5 fundamental elements of any computer program. We know where our first instruction is. It's right there with hello world, right? We are using variables. We got a couple of them here. We have a player variable. We have a player in a row variable, and we're using those. And let's test this out, by the way. Let's go in here, go to line 6, and change it to 3. The value of the player in a row variable is now 3. So go ahead and run it. And now, of course, it says you win. Okay, good. So we're using control and branching mechanisms. We have a control statement. If is a control statement. Else is a control statement. And then we have branches. The branch under the if is printing you win. The branch under the else is print keep trying. It's the computer's turn. So I hope you're starting to see a little bit of like the simplicity of it. Yes, when you look inside a real program, there could be a lot more noise and a lot more lines of code, but they all break down to these 5 elements and no others. All right. Well, now it's time for one of the funnest ones, which is subprograms. So don't worry about coding right now. Let's just talk for a second. As this game is going on, as first the player is taking a turn, and then the computer's taking a turn, and then the player, and the computer, and so on. Every single time one of them makes a turn, we have to check whether or not the game's over. We have to check whether or not the player has 3 in a row. Every time the player makes a turn, we have to check that. Well, I ask you, do you want to type out this set of code over and over and over again every single time the player makes a turn or takes a turn? No, you don't. So if we're going to be checking this particular thing over and over again, let's make a subprogram out of it. Geneva, that's a great point. It's beyond the scope of what we're teaching in this class, but you're absolutely right. So what we're going to do here is we're going to make a subprogram that we can call on anytime we need this particular thing to happen that I've highlighted. Because look at that, over and over again, we're going to need yes, again, I'm being very precise, the thing that I've highlighted, this set of instructions, these 4 instructions, we're going to need that to happen over and over again. So turn it into a subprogram and then just ask that subprogram to run whenever you need these 4 instructions. So how do you do that in Python? Well, go to the very end of your code, hit enter. Remember that you have to go back. And now, just for readability's sake, I'm going to hit enter again. It doesn't affect how the program runs. I just want you to be able to have a little bit of space here, a little bit of room to read the code, okay? So in Python, these subprograms, these programs within your program, we call them functions. Lots of computer programming languages use that term, by the way. There's other terms that are used besides function. Some computer languages call them subprograms even. Some call them subroutines. Some call them methods. But function is used in a lot of languages, and it is in Python. We're going to make a function. The way you make a function in Python is that you use a special instruction called this defining a function. That instruction is DEF. So give me a DEF. Make sure that you've backspaced so you're starting all the way to the left. So DEF is the command to Python to create a function. Well, the next thing you need is you need a name for this function. Because later on in the program, we're going to ask for it to be performed. And so we need a name to give it so we can call it something. So give me a space, and then we're going to give a name to this function. We're going to call it check3. Now, capital C, H-E-C-K, capital T, H-R-E-E. Spell it exactly the way I spelled it. This is the name of our function. So here's an important thing. Functions very often need some information in order to do their job. In this case, the information that this function needs is, well, how many symbols in a row does the player have? And so we can give it that information. The exact term we use is we're passing information into the function. What we're going to pass in is the current value of the player in a row variable. So give me a parentheses. Don't hit space after check3. Do it just like I did it. And inside these parentheses, you can put in the information that you will give to the function. So we're going to give it the variable player in a row. Make sure you spell it exactly the way you did up above. Now, before we keep going, let's make sure we're clear on a couple of terms and just reinforce what we're talking about. Define, DEF, that is the Python instruction to make a function. Check3 is the unique name for the function that we came up with. We decided that. We can call it whatever we want. We can call it foobar. We can call it check3. We can call it did I win? We can call it whatever we want. We decided to call it check3, or rather I did. In the parentheses is information we're going to give to this function we're creating when we ask for the function to be performed. The simple act of creating it, which is what we're doing on line 12, the simple act of creating it does not make it actually get performed. You have to specifically ask for it to be performed. We'll talk about that in a second. But that's what we've done. We've declared, or we've defined a function. We've given it a unique name, and we've indicated what information will be given to it when it's actually asked to do its job. Laura says, how do you know when you have to put a space after something or not? It is a good question. And while every language is a little bit different, there's 2 points I want to make here. One, you can always look up the syntax. And I'm not offering that as an excuse. It's actually a really valuable thing to learn about programming. Syntax is the rules around the exact placement of the words and symbols in the language. It's the rules around how to write it. Never memorize syntax. Never waste your mind, your brain power on memorizing syntax, because you can always look it up, right? The second thing is this, though. There's a couple patterns that are really common, Laura. It's a great question, okay? And by the way, Kevin, I'm going to clarify what you said in your comment, okay? He says it's based on keywords. Keywords need space after them. Let me clarify what keywords are, okay? All of the words that the designer of the computer programming language decided to use for the instructions in that language, those are off limits. You can't use those. Things like DEF. You're not going to use that as the name of a variable, because DEF means define a function. You're not going to have a variable called else. You're not going to have a variable called print. Those words are off limits to you. They're part of the language. They're reserved, is the best way to say it. Reserved words, okay? Now, there's a couple things that are common rules around those words. And the biggest one is this. If the word, it's an instruction, if the instruction needs information to do its job, then you cannot put a space right after it. You have to immediately put a parentheses, and inside the parentheses, put the information. If the instruction doesn't need any information to do its job, then do a space. Like player doesn't need information to do its job. It doesn't have a job. It just is. It's a variable. It's not going to do anything. It doesn't need any information. So you have a space after it. The place where you don't use the space is if you're about to clarify the exact information that instruction will need in order to do its work. That was a good question. I like that. Why is there a box around the first parentheses? Where's my first parentheses? Up here on the top? I'm not sure if I understand that question, Nathan. Why is there a box around the first parentheses? I don't understand by box. Unless I did something wrong. All right. Yeah. Oh, good. Excellent. Okay, cool, Nathan. Thank you. All right. So again, to reset where we are, we're creating a function called check3, right? And check3 is going to take some information in. It's going to take the variable called player in a row. And now we need to say what to do when we call this instruction. When we ask for this thing to be performed, what's it going to do? Well, the syntax to use in Python is you do a colon at the end of this. And guess what? Everything underneath this line that's indented is what you're going to do inside the function. So hit enter. And of course, this code editor is nice and friendly, so it automatically moves over 2 spaces. We are now entering the instructions that will be performed when this function is called. And we know what they are. We're going to check if player in a row space is equal to 3. That's the first thing we're going to do. Because remember, we need to do this over and over and over again. And remember, if is a control statement. So in Python, you put an equals at the end of that. And now watch, it'll indent even more. Because now we're putting down the instructions, i.e. the branch, that will happen only if the condition is true. Only if the variable player in a row, if its value is equal to 3. And we know what to do. It's right above us. You print, quote, you win. Don't copy and paste this. Type it out. Just makes life a lot easier. You learn more doing that way. Oh, it may be like the highlighting. Yeah, maybe Nathan, that's maybe what you saw. And I may have highlighted something like this. Yeah. Okay, good. So we now have a branch. So an instruction to be done if this condition inside the parentheses, if this condition inside the parentheses is true, we have a branch. Well, you know what we need now? We need the else. So hit enter. This part's important. Hit enter. We are not in the right place to write the else. We're still inside the instructions for the if. So backspace once. And now we can write our else. ELSE and a colon. When you hit enter, the editor is nice and friendly, moves you over 2 more spaces. And now we can write the second branch. What do we do if player in a row is not equal to 3? Well, we print, in parentheses, keep trying. So it'll come out tomorrow. Dash, it's the computer's turn. And there you have a function. My lines 12 through 16, this is a function. Now, watch this. Go right above your function, hit enter to give yourself a line, and I want to change the value of this variable. Player in a row and I want to make it equal to 1. And then hit enter. I'll let everybody get caught up. And now I'm about to ask the question. Cassie says, do we need lines 7 to 10 if we were going to write lines 13 to 17? Yes, and we don't need lines 7 to 10. And I had you create lines 7 to 10 just to show why it's valuable to make these subprograms, what we call functions in Python, just to show you, hey, listen, this is how you're going to build some control and branching structure. But guess what? You don't want to have to do that over and over again. So why not make it into a function? That's why we did it that way. Yeah, that was a great question, Dr. Ford. Okay, so everybody go back here. I want to make sure that you have changed the value of player in a row to 1. And now, take your time on this one. Put into chat the exact output you expect to see when we run this. Don't run it. Hello world. Name, Joe, you win. Good. We got a bunch of, we got a couple correct answers. Exactly. Now, did any of you, you don't have to answer this in chat. It's fine. Did any of you think that the final thing that would be printed over on the right would be keep trying, it's the computer's turn? Oh, I put an extra bracket in there. Did any of you think that was going to happen? If you did, I totally understand. Okay. But most of you are probably tracking with something really vital that I said earlier. This function is potential behavior. It is a set of instructions. These 4 instructions, as a matter of fact, is a set of instructions that could happen, but they'll only happen if you later in the program ask for them to happen. And this is how you ask them to happen. Hit enter a couple of times. Make sure you backspace to get back to the beginning, because we're done building the function. The function check 3 is done. The way you do this in Python is you just type the name of the function you want to run. So let's type capital C-H-E-C-K, capital T-H-R-E-E, check 3, and then do a parentheses, and then give it some information. What information do we want to give it? Well, let me ask you a question. And this one I do want you to put in the chat. Right now, on line 20, now we're not done writing line 20. I understand that. I'm just asking a question. What's the current value of the player in a row variable? Put that in the chat. Geneva says 1, that's correct. Nathan says 1, exactly. So let's put that variable in there. Type player in a row. All right, so now I'm going to ask a question about the output, and I'm not going to ask a trick question. What is the final thing that would be printed when we run this? What's the last thing that would be printed? Keep trying, it's the computer's turn. Let's try it and see if I got it right. Here we go. Dr. Ford, do you follow now? I see your comment. You follow why? Yeah, here we go. So first player in a row is 3. And then we change it to 1. And because it's 1, when we run the function, this is not true. So it ends up going to the else and running this branch. Oh, good. Nathan says on line 6, I still have 2. Perfect. Excellent. All right. So what have we covered? Entrance point in Python usually is the first line of instruction in the file. Variables, we've used this player variable and changed its value. Control and branching statements, we learned how to put in a certain condition and do one thing if it's true and another thing if it's false. And subprograms, we figured out how to get a set of instructions that will only be performed when we ask for them to be. And we learned about how to ask. And that action of asking is called calling. You call the function. We called the function check 3. Now, one last thing. Go down to the end here. Let's change the value of player in a row one more time. Let's make it equal to 2 now. And let's call our function check 3, pass in player in a row. Actually, no, let's say we won. Let's make it 3. Make it 3. Let's run it. And the last statement should be that we win. And there it is. We got a win. Okay, good. Oh, Dr. Ford says, before I entered my line 20, this one, when she ran it, it was telling me you win. It was saying that because of this set of instructions right here. That was what got executed and said you win. It wasn't ever actually running this function. I hope that answers that question, Dr. Ford. Okay, good. Awesome. Yeah, you're really bright. Okay, let's show you the next thing. I love this stuff. Hold on a second. Now, let me give you the full code to the Python game. Can you, Nathan, I'll answer that question in a second. Regina, can you drop the link to the full code inside the chat, please? All right, everyone grab that link. You'll see the same Google Doc that I have open right here. Just click anywhere in there, do a Control-All and Control-Copy, copy everything in there, and take it and erase everything inside your code and paste in the new one. And then run it. I want y'all to take a moment and just play a game of tic-tac-toe. So grab that link in chat, copy all the code, paste it over. Like erase everything you worked on and paste it over, and you should be able to play the game. Hey, I won. It's not a very intelligent player, the computer. When you've had the chance to play it at least once, drop a 1 in chat. And then I'm going to take you on a little bit of a tour through this code. Walter, make sure you erase everything that was there already and paste it in. That may be what happened. Laura, surprise, surprise, I won. Also, Walter, make sure you copied everything from the Google file. If you did it manually, it's easy to miss something. Do a Control-A and then a Control-C. All right, good. Now, I want to explain one instruction because we didn't cover it in our instruction. It's this one at the top. It says import. Import means please include a set of pre-made code that my program can use. What this means is some really smart person a while ago made a chunk of code called random. And in that chunk of code called random is a bunch of functions that all revolve around generating random numbers. We didn't want to write that. Someone already did. And if you've downloaded it onto your computer, then you can use it. And it's actually part of this website. So we can bring in this thing called the code library and we can make use of it. Same thing here. Someone made a bunch of code related to keeping track of time. And we don't have to rewrite that. It's really cool. Someone else did it for us and they did a good job. We're just going to import those, bring them into our program, and then we can use them. Now, Lauren will answer that game boot camp question in a little bit. So this is a really important point. Remember that I said understanding what is the first instruction to be executed is really important. When you look at this file here, let's start at the top here. When you look through this, you might think at first glance that the first instruction that gets executed is line 1. This is really important, folks. It's the first instruction that does meaningful work that you care about. This line doesn't do anything. It just tells the computer, hey, make this pre-built code called random available. We're not doing anything with it. It just says, make it available, please. Same thing with this one, import time. Hey, make this available. We haven't done anything with it. And check this out. Line 4, we're creating a function. It's called print board. We haven't called that function. So nothing has happened yet. And then we make another function, check win. We make another function, get computer move. Another function, get user input. Another function, is board full. Another one, get replay input. Another one, this is a function called Tic-Tac-Toe. By the way, this hash symbol means a comment. A comment is just something you can put in your code that doesn't make the computer do anything. It's just notes in the code that help you understand. So here's another function. It doesn't do anything because we haven't called it yet. And look at that line 90. That's the first time in this entire file we actually ask for a function to be done. It's the first time we ask for anything to be done. And this is why it's so valuable to understand there is an entrance point. There's a point where the program actually starts working. All this other stuff above it is setup. It's defining potential behavior. In other words, defining a bunch of functions. It's only on line 90 when we actually ask for a function to be run that the computer program actually starts doing anything. It's a pretty important thing to know, because then you can go to that function, tic-tac-toe, and go, oh, this is where I start. Let me figure out what this does. Tic-tac-toe. Oh, well, it's got this while, if, print. Okay, now I can start reading through here. Excellent. Inside this tic-tac-toe function is where we call all these others. You can see right here, we call a function called print board. Here we call a function called board. Now we declared all these earlier. We have print board right here. We've got some get user input. Those all get used inside this other function. So we're not going to do a full tour through all that code. I just want to point out that one, it only uses the same elements: an entrance point, variables, control and branching, subprograms, and again, with the exit point, which just happens automatically when the game's over. That's all it makes use of. Yeah, they're a little more complex. I totally got it. By the way, when you go through one of our boot camps, you can read through this whole thing and understand every single line. But I hope now you have a little insight that that's all it makes use of, is 5 elements. All right. Let's move on to the next part. Now, I've tried to follow along. By the way, Cassie, Dr. Ford, she's so smart. She says, only thing missing with the code is in the start print of an empty tic-tac-toe table with the grids, as I did not know what A1 or B3 meant. I love that you think with that. You're 1,000% right. And the fact that you think that way makes you a really good engineer or technologist, because you're thinking about the experience of the user. That's spot on. We did this just to put together a quick game. That was a great point, Dr. Ford. All right, so I'm not going to take any more because I've answered most of the questions that come through, okay? And Sumi, there's, in terms of explaining all the nerdy detail inside the code, it's way beyond the scope here, right? I will say you can look up for loop in Python, and it'll explain exactly what you just asked about, Sumi. For loop in Python, and it'll explain everything. All right, now let's talk about the school, the Tech Academy, and what we do. We provide boot camps. We provide a lot of them. By the way, stick around. We've got a free gift coming. It's quite a good gift. If you enjoyed this class, if you got any value out of those 5 basic elements of any computer program, dipping your hands into Python, you're going to love the free gift. Guarantee you. So we have 12 online boot camps, and they cover a wide range of technology subjects. You can see down here on the screen, like artificial intelligence, computer programming, website development, cybersecurity, design, data science, video game development, mobile app development. It's all over. In fact, we have more certification programs than any other coding boot camp on earth. And our boot camps are self-paced, yet instructor supported. They're flexible. Students set their own schedule, and they can enroll 365 days a year. The content on the boot camps is well-rounded and in-depth. The boot camps are affordable, priced under the national average. The programs include job placement training and job placement assistance. And most importantly, they're designed for absolute beginners. No technology knowledge or prior coding experience is required, so you don't have to be a nerd. And who are our programs for? Anyone looking for a better career. Technology is a great career to work in. There's remote work opportunities. They allow for better work-life balance, and technology pays well. So we consistently land on every major best coding bootcamp list out there. What you see here is a bunch of organizations. They're ranked boot camps around the country, and we're always at the top of those lists. Our average review rating across all major bootcamp review sites is 4.8 out of 5 stars, and that's based on student and graduate feedback. Now, you can do a lot of things for a living. I'm going to ask you to consider a couple of things about why would you want to even work in technology. Well, one of them is it has really good work-life balance. You don't work 60, 70, 80-hour weeks. You have the flexibility to have a good work-life balance. In fact, remote work is very possible in a lot of positions in technology, if that matters to you, right? It's also a very creative industry. Even though you're working with machines, you might think that it's soulless and boring. It absolutely isn't. It's very collaborative. There's lots of communication, a lot of creative ways to solve problems, and you can take a lot of personal pride in your work when you and your team accomplish stuff. It's also a very stable industry. Over the last 4 decades, more and more technology jobs come out. And if you are an expert in this area and you're a decent person and you work hard, you'll always be able to find work. And you'll find work that pays well and where you get regular increases in pay. By the way, the average rate in America for a software developer, the average pay is $120,000 a year. Now, you're not going to get that out of the gate, but there aren't that many industries where the average pay rate is 120K. It's pretty cool. Now, that said, there are barriers to doing a boot camp. Again, there's 3 ways to break into tech: self-study, college and university, boot camps. Boot camp tuition, for example, it costs thousands of dollars. What we've done is we provide multiple financing options, including an upfront discount if you can just pull all the money together, monthly payment options if you have no credit or bad credit. There's a tuition option for everyone in all financial conditions. And the big thing I want to say is that doing a Tech Academy bootcamp is truly an investment in yourself. You're giving yourself a long-term skill that can assure you an excellent, rewarding career. Now, another big barrier, it takes time. Like, there's a lot to learn. There's a big required time investment. Some attempts to kind of handle that other boot camps do is they make you join in your boot camp in what's called a cohort. They group everyone together and they all start on the same day. And then they move through the curriculum material in lockstep. Everybody's studying the same thing at the same time. That's one solution to try to, handle the fact that it takes a while to learn this stuff. We don't like that approach. Our programs are online, so you don't have to go in person if you don't want to. You choose your own study schedule, which means part-time study options are available, so you can study concurrently to going to school or doing a job, which is really, really cool. Now, the other thing is, to get through boot camp, you do have to have some technical interest and ability. This is one that's super important to me, folks. You may this isn't true for everyone, but for some of you, maybe along the way, you got some kind of an idea that technology is really hard to learn. Coding is really hard to learn. And I want to tell you that for the most part, that's because a lot of technology education materials are too difficult, unnecessarily so. It's because a lot of educators assume too much prior knowledge on the part of the learner. With our programs, you don't have to be a nerd. You don't have to have been like deep into science, technology, engineering, math all your life. In fact, you need no technical background to enroll and succeed in the program. So I have a question. Are you perhaps like working in a dead-end job where you look at the pace at which you can increase your income, what the positions are above you, and there's just a ceiling there, or it caps out at a low wage? Maybe you're even unemployed. Perhaps it's really important to you to work from home, but you're working some kind of a job where remote work would never be an option even, or that industry will never tolerate it. Or maybe you just want more time with your loved ones and a job that has better work-life balance. In other words, is it time for a career change? If it is, Tech Academy is the solution. We're career change experts. Our symbol is a bridge for a reason. We represent the route into tech for everyone. Crossing that bridge that covers this chasm of uncertainty and confusion about technology. That's what we do. And at this point, we have a decade of experience breaking people into technology. Now, I talked about the average wage across the board from beginners all the way to super experienced software developers. And in America, it's $120,000 a year on average. And what's really cool? Most Tech Academy grads make on average $30 an hour in their first job. That's $60,000 a year. And that's not just a few people. We have over 1,000 graduates working in technology now. And they work anywhere from small businesses all the way to the big tech companies like Nike and Facebook and Disney and Uber and Epic Games, right? So I want to remind you, we offer open enrollment and you can start anytime. So I encourage you to enroll now. It is a phenomenal experience and well worth it. If you want to do that, it's simple. Just go here. In fact, Regina will drop that link into chat. This is the Erik link, where you go to our website /Erik, and it's a super simple contact form. There's a couple fields to fill in. But what's cool is after that form is a series of steps all about the Tech Academy. Videos and articles and even an optional step to book a call with our admissions folks so that you can get all of your questions answered. It's a big decision, but we're going to give you lots of data to be able to think with. So if you fill that out, just finish the steps on it after the event. I'm going to stop for a moment and take a sip of my coffee and give anybody who wants to fill that out a minute. By the way, if you go to that link and you get a login page, it just means you have an existing account with us already. And you can see how to do the username and password right at the bottom of the screen. And don't go anywhere. Your free gift's almost here. All right. So here's a really cool opportunity to help your friends. I mean this sincerely. Our graduates really, really love us. It warms my heart whenever we hear from them, and we hear from them often. And because of that, referrals from students and graduates have been one of the top enrollment sources for us for years. And because of that, years ago, we put in a 5% commission payment for all referrals, for anybody who enrolls. That's not just for students and graduates, though. Anyone can get that referral commission. So in a minute here, in terms of the free gift, we're going to give you an email address to use. When you email in for your free gift, you can include the name and contact information of anybody you think should talk to us and find out about us. And if they end up liking what they see and they enroll, we'll send you a check for 5% of their commission, their tuition that they pay. And you will be doing a wonderful thing. If they find a really good fit here and enroll and break into tech, you've changed their lives. No kidding. All right. A brief note on this. We have 7 publications we've written over the years, including 3 Learn Coding Basics in Hours books, a coding book for kids and young adults, a technology basics dictionary, a project management handbook, and You Are Not Stupid. Now, You Are Not Stupid is an amazing book. It's basically a written version of the most important course in our whole boot camp. called the Computer Basics course. It removes all mystery and confusion from every aspect of technology. The book has all modern technology terms and concepts defined, and it even includes a history of technology that shows how we arrived at where we are today. Obviously, Jack and I are biased, but it's a phenomenal book. Laura, yes, this video is available on YouTube, probably within a few hours or tomorrow morning, tomorrow at the latest. I'll give you that link later. So this is our free gift. If you liked what you got your hands dirty with a little bit about Python, you're going to love this book. It is our Learn Coding Basics in Hours with Python book. It expands with even more detail on those 5 fundamental elements. It goes into a lot more detail about the Python language. It's written on a smooth gradient. It's an awesome book. If you want your own copy, it's a physical copy. It's large. You can fold it open. You can go through and do all the exercises. We'll send you one. Just email us at books@learncodinganywhere.com. You can see that in the chat. So you just copy it if you want to. And this is only for people in the United States. Sorry. If you'll send us your name and your full mailing address, we'll send you one. Invariably, every week or two, someone forgets to put their mailing address in there. Give us your address. We're not going to sell it to anybody. We just want to send you the book. Okay. And again, if you're sending this in, you can include referrals. And if there's other questions I wasn't able to get to tonight, throw them into the email. Those always get forwarded to me. I always respond, and I'd love to hear from you. All right, so I'll give a minute for anybody who wants to grab that email address and send something off. All right, now I've mentioned links several times, and to make it easy for everyone, we put all of our links in one place. Go to this URL. Regina is going to drop that in chat. We use that service Linktree. It's really cool. And when you go here, you'll find all the needed links for the Tech Academy. Links to our free educational YouTube video playlist, which is where you'll find this recording within a day. Links to our books and our dictionary, upcoming meetups. If you want to find out about future classes, then it's in there, and all of our social media accounts. So please follow us on social media, invite your friends to future meetups, and tag us. And in fact, if you'd like to have a chance at winning your own copy of You Are Not Stupid, it's a big book. Okay, it's well worth the read. But it's a big book, right? If you want your own copy of You Are Not Stupid, you have a chance to win one of these, and it's real simple. Just go and get the link to our next event and post it on social media and tag us. It's that it. It's that simple. It's that it. I speak really good words. So yeah, if you just tag if you'll just tag us when you've mentioned, put in a link to our next event, obviously we're going to know about it because we get the tag. We'll put your name on a list. We pick someone at random, and they get a free copy of You Are Not Stupid. All right. So if you filled out the form, and here's the link again, okay? If you filled out the form, please, after this, this event is over, go through those steps, find out more about the school, see if it's the right fit for you. I want to thank you all so much for attending. I love the questions. I love it when the students are super involved and trying out the code and have questions, and sometimes it works and sometimes it doesn't. I love hearing from you, so thank you all for that. And please come to our next event.